Yowzers. It's Sunspot 2815. The newest sunspot rising here in the southeastern limb of the closest star, El Sol. And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we'll be talking about that sunspot, showing you imagery of it, talking about M87, Jupiter's Aurora, and the youngest supernova. Also an SDO calibration maneuver going on here. And here's some more imagery. So here's colorized magnetogram, and we do see some areas of magnetic organization happening up here in the north as well. You can see some areas here that are showing some magnetic organization. Sunspot 2814 has remained fairly stable here over the past 24 hours. So possibility for solar flares has gone up a little bit, folks. Here's a full disk view in 304 angstroms showing you that full SDO calibration maneuver, where the SDO makes sure that it is aimed directly at the exact center of the solar disk. We do see some filaments right around the solar equator there on the east as well. Likelihood of coronal mass ejections not particularly high, especially for the Earth-facing zone. Here's a close-up of the southern hemisphere in that same ionized helium wavelength. Here it is in ionized iron, 171 angstroms. And here's a close-up of the new sunspot rising in 94 angstroms. And a little bit of flaring happening there. It looks like the B-class flare we saw right around midnight did indeed come from the new group. Here's a full disk view in 193 angstroms. And we can expect a coronal hole wind stream in about 36 hours from this sunspot, from this coronal hole right here. Some delightful imagery there from the Solar Dynamics Observatory. And here's a diagram of the solar system. There's where things will be in a week. Here's a star chart. It's from in-the-sky.org. Mine faces south, and I keep the ecliptic drawn in. And if you've got clear skies here up before dawn, you may see Saturn rising ahead of the sun as well as Jupiter. Radio flux only at 74 solar flux units. Here's a one-year chart of the radio flux, which is this top black line. This red line down here is the sunspot number. And our regular viewers would be well aware that the radio flux and the sunspot number are proportional data sets, as you can see on these charts right here. And this is the Space Weather Enthusiasts dashboard. So some activity kicking off here once again as solar cycle 25 progresses at a surprisingly slow rate. And here you can see actually the NOAA forecast actually now includes a brief period of geomagnetic storm forecasts for the 17th. So late the 16th and into early the 17th, a brief period of geomagnetic storm forecast from that coronal hole. So late tomorrow into the 17th. Let's talk about volcanoes. Soufriere has been erupting. Here's some satellite imagery of the stratospheric scale plumes that happened, spreading volcanic ash thousands of miles away into the Middle East and Africa. So it's some natural geoengineering going on there, folks. Some natural geoengineering happening. And let's see what else is erupting at volcanodiscovery.com. Today's list includes some new entries once again, and some old ones like Sakurajima. So Sakurajima on the list now, flight level 8000. 0808,000 feet is the altitude of the ash plume there. Cadavar now back on the list, exploding. 6,000-foot ash plume. Cinnabung, flight level 130. It's a 13,000-foot ash plume. Similarly sized ash plume over East Java, Indonesia, as Semeru now explodes. Popocatépetl exploding as well. 23,000-foot ash plume there. Fuego in Guatemala, no volcanic ash observed down there. Sabancaya in Peru, also exploding. 24,000-foot ash plume. And on Solfuyer, the aerosol plumes, mostly tiny droplets of sulfuric acid in the stratosphere, as well as some very fine ash particles, have been traveling along vast stretches in the northern hemisphere. The latest satellite data show plumes from the eruptions in the past 48 hours extending hundreds of miles over the Atlantic to the southeast. Earlier eruption plumes have been reaching Africa and the Middle East. A great reminder to not pole vault the caldera. Dear viewers, please do not pole vault the caldera. This public service message brought to you by smAshomash.com at massive personal risk and expense. We saw a 4.3 magnitude earthquake in the Texas stovepipe. Leave us a comment if you felt that quake, Texas viewers. Also, it was felt in Oklahoma, it looks like. Amarillo. A 4.3 magnitude earthquake happened. And that happened at 23:54. So 11:54 p.m. Universal Time was the time of that quake. Let's check what else was going on. There was a deep quake in Afghanistan. One of the largest quakes of the past 24 was this 5.5 magnitude quake at Indonesia. And we're just going to let the list scroll here as it's been pretty quiet as far as earthquakes. Looks like a small swarm there in Oceania near Fiji, including this 4.4 magnitude quake at over 600 kilometers depth. That one coming in at 2:46 this morning. We saw a deep quake at Peru and a deep quake at Wallis and Futuna. So there's a deep quake, and then half an hour later, one in South America, and then only 7 minutes later, another one in Oceania. A little bit of deep quake ping pong going on there. And continuing on here, no major solar flares, but we saw one happen just after midnight. Peak flux occurred at 10 minutes after 0000. So at 12:10 Universal Time, small B-class solar flare happened, which we showed you earlier in the video. Proton flux shows no strikes. No surprise there. We did see a brief period of geomagnetic unrest here associated with this sudden dip in the GOES magnetometer reading. Not really any other signals associated with that, so you won't really see anything in the solar wind. We'll show you momentarily. First, more magnetic data. That's the GOES magnetometer over the last 3 days. Here's the magnetism of the current sheet. And the green portion of the current sheet here is polarized by the north solar polar field. The red portion of the current sheet polarized by the south solar polar field. Earth solidly in the south pole current sheet. No expectations of that changing anytime soon. Here's another view which shows you the rather massive and very well-defined coronal holes in the south, starting to reach up pretty close to the equator there. And here's the line of sight ecliptic plane field plot, which shows you sort of a three-dimensional imagery of the potential field surface source lines. And that blue line is essentially the extent to which one or the other fields is dominating the total magnetism sensed here at Earth from the closest star. When the line's up like that in the north, that's an indication that the south is providing the magnetic polarity in the earthly portion of the heliospheric current sheet. Next, detected filaments and sunspot groups. I only really see one umbra associated with this new sunspot, and it's not named yet, but it's going to be named 2815. It's quite large, and unless it suddenly evaporates, which I doubt, my best guess would that it would be a beta-class sunspot right away. Like 2814, although it looks larger than 2814. And the KP index currently at 3. So we did see an uptick in the solar wind density also, folks. I think it's a minor coronal hole wind stream associated with the coronal hole ahead of sunspot 2814. And just to tell you what I mean, you see this little coronal hole right here? I believe this little pulse that we see is a result of that coronal hole. Next, the real-time solar wind. And we just saw the BTBZ diverge big time, and then a sudden shift. So here you can see this sudden shift here, the BTBZ. The BT is the white line, and the BZ is the red line. Suddenly shifting from north to south pole magnetism there. And still increasing as we make the video. Current solar wind density, slightly elevated here at 11.33 protons per cubic centimeter. Solar wind speed, 387 kilometers per second. So it looks like a very weak coronal hole wind stream associated with that small coronal hole leading sunspot 2814. And we can expect much more significant, more geo-effective inputs from the larger trailing coronal hole. Next, geospace magnetosphere movies. And since we saw some fluctuations in the density, we decided to show the density today as well as the pressure. Density is shown in protons per cubic centimeter. It shows low density in white, high density in dark blue. Some pretty great imagery there of these changes in the solar wind density. It's 4 hours of data. Here's 4 hours of data of the pressure. This magnetohydrodynamic pressure measured in nanopascals. And you can see quite a bit of pressure here in the magnetotail, less so in the bow shock at the beginning. And then some minor pulses here of increased pressure, followed by an equalization of the pressure. We'll also show you ground magnetic perturbations. Geospace delta B, changes in the Earth's B field, and we'll let that play through as it refreshed. We strive to provide our patrons with the most current data. And you can see some significant magnetic perturbations there near both poles. And some interesting stuff about magnetic fields coming up in the cosmology segment. Again, that's 4 hours of data. You can see that situation calm down. We've got a Discord channel. Were you aware? You can find links to it at smashamash.com. You need an invite, and there is a permanent link there. Now, we also do regularly stream live to Twitch, twitch.tv/smashamash. Thanks to our Twitch subscribers. Most importantly, youtube.com/smashamash. Check out our playlists. There are playlists with different subject matter there as well. Perhaps check out our Do One Thing playlist, which we'll be adding to soon. And thanks also to our BitChute subscribers. And let's take a moment to welcome our Twitch viewers. We've gone live to do today's cosmology segment. So today's cosmology segment is super exciting. And here's why. First of all, Jupiter's aurorae are in the news. Here's a close-up of one of Jupiter's poles and the aurorae associated with it. And I just wanted to talk briefly about open versus closed magnetic field lines. So in these areas here where it looks dark, you've got actually open field lines, which is why there are no aurora there. These areas right in here are open potential field force lines. But where you see the aurora, those are closed field force lines. Here's a full planet view of Jupiter's Aurora. And here's an article about it on SciTech Daily. So some interesting insight here. Turns out that Jupiter's polar regions are actually a combination of open and closed potential field surface source lines, magnetic field lines. Some stretch out into space where you see no aurora, and some reconnect with other portions of the planet. Jupiter's magnetosphere is so huge and powerful that if you could see it from Earth with the naked eye, it would be about the size of the full moon. And everybody's probably well aware that Jupiter only looks like a small point of light, like a bright star. I'll just let the article scroll here. Again, that is from scitechdaily.com. I don't know why we've got medical stuff on the screen. That was not my plan. Now, there's nothing random about V906 Carinae. Here's a simulation of V906 Carinae, which we, quote, randomly end quote, selected yesterday as a random object to feature in yesterday's cosmology segment. It's just a simulation, folks. But what it is a novel remnant area discovered in 2018. And you can find all kinds of information about this if you'd like to read about it. V906 Carinae. Now, let's talk about something much larger. The massive radio source located at the core of galaxy M87. So now this has been all over the news in the past couple of years. And we've got an incredible article here featuring data from 19 different facilities on Earth and in space. So you can see Hubble Space Telescope and Chandra and SWIFT and ALMA and the VLBA and the EAVN and so on, the EHT. And this is all about this article here. Unprecedented observations of the famous black hole. The quote, black hole, and quote. You can find links to all of that at SciTech Daily. Absolutely fantastic analysis. All kinds of close-up imagery of jet features. And we may have to make a video just about this paper. So check that out. Again, you can find links at scitechdaily.com. And we don't mean to promote the publication every single day, but hey, there's a plug once again. Probably my favorite science publication. An absolutely fantastic study here, again from 19 different sources, including the EHT, ALMA, EAVN, VLBA, GMVA, Hubble Space Telescope, Neil Gorel Swift Observatory, the Chandra X-ray Observatory, the Nuclear Spectroscopic Telescope Array, Fermi-LAT, HESS collaboration, the MAGIC collaboration, the Veritas collaboration, NASA, and ESA. And that's today's cosmology segment. See you later. Twitch will be back for a meteorology segment. First, we'll talk electrons. Here is the one-year chart of the electron flux, and we're seeing continued low levels, and we're going to expect to see continued low levels of electron flux continuing here as coronal hole wind streams strike. So here's the last 3 days. You can see quite low levels of electron flux here. And I would disagree with the forecast model here. I think it's going to remain pretty flatlined here. I don't think there's going to be any uptick, particularly in the electron flux. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts. There are two of them usually, although during times of geomagnetic storm we sometimes get a third. Distances here are listed in miles. The International Space Station orbits at about 230 miles. And here's a visualization of the total electron content. And we expect to see anomalies here. You may see GPS errors at nighttime due to high levels of electron flux, and you can see indeed there at nighttime some blobs of electrons. Normally you see the largest GPS errors around the equator at noon, as GPSs have to communicate through a giant blob of electrons suspended above the Earth in the Earth's magnetic field lines. Here's another diagram of the atmosphere. It shows you things like the penetration of electromagnetic radiation, as well as this red F, which is the F ionosphere layer. And that's what we're showing you now. This is the vibrational frequency situation at about 300 kilometers of altitude. The F ionosphere layer, folks, and it's looking a little bit anomalous here. And I think that's to be expected when we see these very low levels of electron flux, as there are electrons in places they aren't normally located. When we see higher levels of electron flux, we see more organized Van Allen belts and more chaotic ones at low levels of electron flux. And each tick of the chart here is 15 minutes of time elapsed. This data courtesy Bureau of Meteorology, Australian government. And the ionosphere is looking a little anomalous here. We show it daily to help folks tie together the physics. You can see some sudden charge ups and charge downs happening, and some surprisingly large blobs of high frequency vibrational regions here. And the units here are megahertz, millions of vibrations per second. Here's the latest image coming through at, wait for it, 7:45 Universal Time. Next, we're looking at the jet streams here of the South Geographic Pole, and it's pretty windy around Antarctica, as you can see here. Strong winds, pretty much completely encompassing the South Geographic Pole. Let's look at jet streams. And there's the jet stream of that area. Let's look at the jet streams of the Western world. We'll show you the Northern Hemisphere also. It's a special feature. And let's actually welcome Twitch back. Hey Twitch, welcome back. It's our meteorology segment. We're looking at the jet streams of the Western world here. Here are the jet streams of the Eastern world. Here's the North Geographic Pole. Here are surface winds. And here are the surface winds in the South Geographic Pole region. Strong winds all around Antarctica. Next, looking at windy.com, here are pressure maps. And you can see the way the southern hemisphere, the South Geographic Polar region, completely surrounded by low pressure. Low pressure and high winds. Here's where the GFS forecast places pressure cells tomorrow at 12 noon Eastern Daylight Time. Continuing on to lightningmaps.org, and we've got some terrestrial lightning once again here in Louisiana. Looks like thunder rolling in toward Alexandria, as well as northeast of Baton Rouge. So some significant thunderstorms happening there, mainly in places like Mississippi and Louisiana. Also some off of the Atlantic coast. Here's your U.S. Doppler radar map. Arkansas getting some precipitation, as well as Wyoming. Some heavy snow falling there in the Central Rockies. It's April 15th and it's still snowing. Here is the cloud layer. It's 3.9 nanometers radiation. The wavelength of 3.9 nanometers, folks. Shows you the clouds at nighttime. And here's the water vapor map. Powerful low pressure system. Still hanging out here. Stagnating, actually, for quite a while there. And some moisture making its way across the central portion of the country, as well as around the Gulf Coast. And we do see some huge pressure gradients down here, creating some turbulent weather. Again, there's the cloud layer, and there's the water vapor map. These are the GOES interactive weather satellites, folks, and you can bring these up yourself if you like. They'll give you insight when the Doppler radar isn't helping. Again, there's the Doppler, and there's the cloud layer, and there's the water vapor. Thanks for tuning in, Twitch. We are out. Again, Twitch viewers, don't forget to check out our playlists at youtube.com/smashomash/playlists. Heading back to bonus features, we're going to show you the latest imagery here of the sun. This one is 4 minutes and 21 seconds old. It's hydrogen alpha from the ground-based solar telescope at Udaipur, India. And it looks like a cloudy day at Udaipur, India, although you do get a view of Sunspot 2814 and some filaments when those clouds are not in view. Thanks to the SMASH team. Hey, SMASH team, would you like a 1-month Patreon membership? All you got to do is win a slam poetry contest at smashomash.com/forum. It's free to enter. Thanks to our patrons, the true source of funding for the content. Patreon.com/smashomash if you'd like the earliest alerts and all kinds of other perks. Patreon.com/smashomash. Again, you can win a free month of Patreon at the $3 per month tier at smashomash.com/forum. And here come the rest of our bonus features in the form of the high-resolution magnetogram. So here's Sunspot 2814, which has actually gained intensity here. We see an organization of the trailing umbra, that North Pole umbra there, that North Pole umbra, an area of magnetic organization behind it. And there's likely Sunspot 2815. And here's the intensity gram. There's Sunspot 2814. This one here might be named Sunspot 2815, as it's already got umbra. Pretty weak, but still umbra. And you can see a small dark spot here, so we may have actually 3 different sunspot groups. This may be 2816, but if this one remains intact, it will be 2816, and this one will be 2815. Here are some more images. It's the full disk 171 angstroms view. And we'll close things out with a close-up of this active region, likely to be named a sunspot today. And thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Don't drink it. If you do, don't drive. Visit our links, support the channel in whatever way you see fit. Thanks again for tuning in, and may that solar wind be at your back.